Hi, cool coders. Today we're going to be looking at functions in Python. Now, functions are a cool way to create code that you can use multiple places in your program. Now, we've created loops to create code that is reusable in the context of a loop, but a function can be called multiple places in your program. It can be called in a loop, outside a loop. It's really just a way of encapsulating a piece of code that you use over and over and over again that you need to call over and over again multiple times in your application. So let's dive right in and see what these look like in Python. So functions in Python are pretty straightforward. So I have here, right here on the screen, as an example of a function. Now the function itself starts with the def keyword. So the def determines that we're defining a function. And then what we do is we give the function a name. This is what I'm going to be calling in my code when I actually call this function whenever I want to use it. And of course, because it is a code block, I'm going to need my colon right there. So once I have my signature set up, this is what this is called, as a signature, then I can have the code inside of my function denoted by a code block right here. So this one is just printing out hello world. And so this is a fairly straightforward function. It's really not doing anything particularly novel, but it does allow me to call this function over and over again. So I can say hello multiple times in my applications, and once right here and then again right here. And each call to that code will do the exact same thing, print hello world. But in this case, I'm not just calling print hello world directly, I'm doing it by way of a function call. So this is a pretty straightforward concept. There's really not a lot to it, but this is what we're going to build on when we talk about functions, because there's a lot more than you can do with functions than merely call a print hello world statement. You can do a lot of other cool things that we're going to look at in the next few slides. So when we talk about functions, there is a way to get data into a function, and that is by way of parameters. Now, we've used parameters before when we were looking at different functions that are built into Python, and we've called the print function, for instance, to print text back to the shell, and we passed in parameters into that function that was usually string data, and we're calling a built-in function. Now with our own functions, we can set these up using def as well, where we have define right here and then the name of our function, say hello, and then I can have a parameter inside of my parentheses right there, and of course my colon for my code block. And then once I'm inside of my function here inside my code block, I can use that parameter right inside of my code block right there. So what I call right here, the name of this name, really, this is the parameter that I have. The name of my parameter is name. The value of that parameter at the time it is called an argument. So a parameter is the actual name of whatever the function is receiving, and the argument is the value of that parameter once it's called. Sometimes you'll hear people use these interchangeably, and for the most part, that is perfectly fine. I use them interchangeably a lot of the times when I'm talking about code inside of many different languages. But the basic difference between these two is a technical difference. Parameter is the name of whatever you're using in the function, and the argument is the value. In any case, you can use them interchangeably, and most people are going to know what you're talking about. So when I'm calling my function down here in my two examples, I'm going to say hello Bob. So this is the argument that's going to get passed into the name parameter here, and then it's simply going to get printed back to the screen using the print function that's embedded inside of my function. And I'm going to say hello, and then the name of the parameter that is assigned to that name, right? So hello Bob or hello Jack. So in this case right here. So you can see here that I have a function that I'm calling twice, but in this case, I'm using two different arguments for that function. And then I'm just handling that data as if it were a variable inside the code that is embedded inside of my function. So this is a great way to encapsulate code that you use over and over in your program. And when you get more mature in your programming, rather than having a bunch of monolithic programs like we've had up to this point, you can break up your programs into smaller sections and then create reusable code like this with functions. And there's some other abstractions we're going to talk about in future videos, but functions is one of the most primitive ways to do that, and it's also one of the most useful ways to do that, and you're going to be using these a lot as you mature as a coder. Before we go over to Tony, I wanted to look at how to get values back from a function as well. We've looked at how to get data into a function. I want to look at how to get it out, and that's what we have here. And for a return value on a function, we use the return keyword that we see right here. So we have this add function right here, and it's going to accept two values, val1 and val2. And val1 and val2 in this add function are going to be added together. And I'm going to take the value of val1 and the value of val2. Those are my arguments that I'm going to be passing in, add them together, and then return those back to whatever called this. So in this case, I have a variable down here called mynum1, and it's going to say equals. So this is getting a value back from this. So this is going to return the sum back to the calling of my function right here. So add 2 plus 2. So that's going to call this function and this is going to have value of 2. This is going to have value of 2. Those are my arguments, and then it's going to add them together and then return that sum as 4. And then it's going to be then assigned to my variable right here. And the same thing down here, I'm going to pass in 2 and 4. So instead of the value of 2, I'm going to have the value of 4, and then it's going to add those together and then return those back down here to this variable, mynum2, and it's going to be 6. So that is how a function can receive data. It can also then return data back to whatever called it. And then you can assign that to a variable, just like we saw when we were calling other functions. And those are the built-in functions in Python. So your functions can receive data. They can also output data. Now, of course, both are optional. You don't have to pass in any parameters, and you don't have to have a return. It's really going to be shaped by how you use the function and what you need it for. So let's go over to Tony and take a look at a couple of examples of these. And I want to show you some ways to use these functions so that you can control input and program flow in such a way that it can prevent people from doing bad things with your program. So let's go over to Tony and take a look. I'm using Tony for Windows today because my Raspberry Pi is being used for something else at the moment. So let's just create a function here, and let's do define our function first. So let's do my hello world function as we saw back in our code. So I'm going to have hello world, and I'm going to have no parameters, and there is my colon. So it's going to detect my colon, so it's going to give me a new code block here. So next thing I'm going to do is print hello world. And let's close that up, and let's come down here and then call this. So if I just call hello underscore world like that with no parentheses, with no parameters in my parentheses, and simply call this, it's going to print hello world. Now let's step through this so you can get a feel of what's going on inside of my program here. So I'm going to put a breakpoint right here on hello world, and I'm going to debug the script, and it's going to then break on this. So I want to step into this. So let's go into hello world. So what this is going to do is come into my hello world function right here. So notice what it did is went up to the hello world. It kind of did a pop-up window here with hello world code right here defined, rather than go underneath to this one right here. And it's stepping through this, and then I can step into this, and it's just executing that line of code, and it's going to print that back down to the console, and that's my shell. And there it goes. And we can step out of that, and it's just coming back, and it exits my code right there. So you can see right there where it did my execution of hello world by stepping through the code. So let's add a little bit to this. Let's do a new function here. You can have multiple functions inside of a program. So I'm going to call this one hello, just like we saw with the name. And what I want to do here is have a name parameter. So let's get my colon right, and let's do print, and let's do like we saw a minute ago, hello, comma, and then plus name. So my name is the name of my parameter. And let's call this down here, hello, and I'm going to say Blaze. And let's see what happens if I call this. As you might expect, it's probably just going to call right here. Let's hit the debugger. And if I just step over this, it's just going to call hello Blaze. And if I put in another parameter there, I can do hello Bob and call the same program again, and we get hello Bob as well. So I'm calling it twice, once right here and once right there. And if I wanted to call it a third time, I can always, put hello Sue, and there we have hello Sue. So I can call that as many times as I want, basically as many times as I'm allowed to inside of Python. So that is one way to call these with parameters. Now let's go and create a new file and get some data into our program into our function, and then let's use that data in our function and then return something from it. Okay, I have here a new file, and I'm going to start off by creating a function that returns some data. And that's just going to reuse our add function that we saw already. So val1, val2. And all this is going to do is return val1 plus val2. And now this isn't too earth-shattering here. You need my colon, of course. And I'm just going to print out the result of that. Add 2, comma 3. So it's basically adding 2 plus 3, and that should return 5. And that's exactly what we get right there, 5. So this is a very trivial example. So what this is doing, though, is just basically passing in 2 arguments into these parameters, adding them together, and then printing it back to the screen. However, I want to do something that's a little bit more advanced than a trivial example here. This is one of those cases where I think you can use a function that will get some data from the user, and you can use the function to control what the user inputs. So my function is basically going to receive a parameter that's the name of a variable, and I want to say enter a value for this parameter. And then from there, what I want to do is force the user to input a number, and I won't exit a loop until they actually input a number. So let's look at how we can do that. So let's say define new function. Let's call it get number, and then I'm going to say var name or something like that. And that's just a variable name that I'm passing into this so that I can display something meaningful. So this is not going to be really used to determine the value of what I input. It's just going to be used for display purposes. So let's use this as my example here. So let's do this. So here I'm going to create a variable called val, and I'm going to set that to nothing. And then I'm going to set up a loop. I'm going to say while val, and then I'm going to call a string function that's built into string. We've used string for casting. I'm going to call a built-in function called isNumeric. And what this does is test to see if the value of a variable, a string variable, is numeric data. That means, is it a number that's contained within the variable? And if it's something other than numbers, like a character like A, B, or C, that is not numeric. And so this will return true if it is numeric. It will return false if it's not numeric. So I want the exit condition for my loop to be the event when somebody enters numeric data. So while it's not numeric data, continue looping. And so what I'm going to do inside my loop here then is I'm going to say input. I'm going to say val equals input. And then I'm going to say a string. Enter a value, a numeric value for, and then I'll close up my string, and I'm going to say var name. And then plus, let's just put a colon after that to make it look nice and neat. And there is where I'm using my variable name. So what this is doing is it's just prompting the user to enter a value for var name right here. And then it's going to continue to loop while that value that's entered is not numeric. So if I enter a number, it exits a loop, and then I can then do something with that. So once I have a numeric value in my string, I need to return that value. But to return it as a number, I need to cast it. So I'm going to return, and then I'm going to cast it to a float. Since I could enter a decimal, that's technically numeric data. And so what this is going to do then is, because this is guaranteeing that this is going to be numeric data, what this will do then is cast that to a float. And I know that I have numeric data because the user cannot exit this loop until they enter numeric data. I can easily cast that to a float value and then return that. So that's basically just going to take whatever's entered it right here as a string, cast it to a float, and then it's a number. So now I can use this function to get numeric input from the user that is only numeric input. So this will guarantee that I will get a number from the user. Very simple function here, but it demonstrates a way to use functions that can be used to control what your user inputs. So we used this one right here to hard code values into the program using add 2 plus 3. But what now I want to do is I'm going to get 2 numbers, and then pass those new numbers that the user inputs into my add function. So to do this, I'm just going to create two new variables. I'm going to call my num1, and then I'm going to call get number, and the parameter for this is the variable name. So it doesn't have, I can put anything really here. I could put in my name or whatever, but I want it to be meaningful. So I'm going to put in get number my num1. And so that's what's going to be displayed right here. And so this is going to get a number and assign it to this variable right here. And then I'm going to basically say, do this exact same thing, but I'm going to get a new variable here and do it to my num2. So in both cases, this variable are getting a number from this function, and this variable is getting a number from this function as well. I'm calling it twice. And so what that allows me to do is reuse that same code on two different variables, rather than having to write the same code twice. I encapsulated it in a function right here, and then I can reuse that same code over and over. Anytime I need to get a number in my program, I can simply just say get number, and it will call that same function over and over and over as many times as I need to use it. Now, since I have those variables, I can then call my other function, my add function. So then I can say add my num1, and since these are numeric, this is numeric data, I can pass this data into my other function and then get back a value from it. So this is basically getting a number from here and another number from here, and then it's assigning those to variables, and then it's passing those into that original function I wrote to add those together, and it's going to print that value, whatever's returned from add, back to the screen. So let's test this, make sure there's no bugs in it first. So we called that first one 5. That's, you call this line of code right here, and that's what that print is. Now it's saying enter a numeric value for num1. So if I try to enter in some, string data, it's just, even if I have, numbers inside of my data, it's going to continue to prompt me until I enter some numbers. Let's say 4. Now, notice what it did now. Enter a numeric value for num2, and I can't enter in that data here until I enter in, say, 4 or 5, right there. And see, now that I had those variables assigned to value of 4 and a value of 5, it returned those back to both of these variables right here, and then it passed those into the print command right here. But first it did the add function with those two values, 4 and 5, and then it added those together, and then finally printed that back to the screen as a sum. So you can see here where I am using a function to get data, assigning that to a variable, and then passing that into another function, and then using that data in my second function. So this is an example of two functions that I'm using over and over and over in my code, but I'm also using it for more than just a trivial example. I'm using it to control what the user inputs, and that's really a good use for functions. It's one of the many uses of it, but this is one example where I wanted to show you where you can use this. So pay attention to this code, because I want you to use it in the challenge later on. You can take my code right here basically and just use it in the challenge later on. You'll see when I present the challenge to you how you can use this. So let's revisit this later on, but for now, let's go on and look at some other cool things you can do with functions. Another cool thing that you can do with functions inside of Python is have default values. Now, default values are good for whenever you want to prevent people from passing in data that is bad data. In other words, they don't pass in a particular value and you still want to be able to call that function. You can have default values that are used inside of your function. So let's look at our example here on the screen. I have add, and then I have two parameters. I have val1 and val2, and each one of them are taking a default value of 2. If I didn't call add with parameters, it would simply use the default values. But and that's what this example right here is doing. And so what it's going to do is simply assign 2 to val1 and 2 to val2, and then add those together right here, and then return that value. And then if I called it with, say, just one value, what that's going to do is insert that into val1 because it's the first one. And then what it's going to do is use the default value for val2, in that case 2. So what that's going to do is say this is going to be 4 now, and that's going to be 2, and it's going to add 4 plus 2 and return 6. And there are other ways to call functions inside of Python where you can use names of parameters in the actual call itself. And we'll look at how to do that when we go to Tony. But the ability to do the function call with default values is the ability to control the input into your function even more so than what we saw already. So if I wanted to reuse that function where I had keyboard input and there was nothing inputted into the variable name, I could just assign a default value to that and not have to worry about them passing in something into my function. I could just say empty string for that, and it would just say enter in a value, and that would be the end of it. So let's go over to Tony and take a look at how we can use default values in our code. Okay, I'm back here inside of Tony, and I want to basically reuse some of the code that I have here. I'm going to reuse these two functions right here. I'm going to copy and paste them into my new default.py here, and this is my add function. And I'm going to assign some default values here. I'm going to say 3 for val1, and I'm going to say 4 for val2. And so let's just call these for now. Let's just call the add function here. So print add without any parameters. And let's see what happens. So if I call this, I would expect that to add 3 and 4 and get back 7. So this has no parameters, so it's simply just going to use the default values. Now let's call add again, but let's just pass in a single parameter. So let's pass in 1. So I'm going to add 1, and I would expect to add 1 and 4 together. So I'm going to expect this to return 5. And that's what we have right here. So 5 is the value I got back from this, because this one took the value of the argument I passed in, which is the first one in the list. And then the default for 2 for the second value for val2 was 4. So it took the default 4 and the argument I passed in, which was 1, and then added those together, and that's how I got 5. Now, if I wanted to skip past val1 and simply assign a value to val2, I can do that too. But the way to do that is to call it by name. So if I said val2 equals like this, what this is going to do is set the parameter val2 up here to a value that I assigned down here in my function call. So in this case, what it's going to do is take the default for val1 and then assign val2 to 1, to the value of 1. So if I take the default for val1, that's 3, and then pass in a value for val2, it's going to take 3 plus 1, and so I'm going to get 4 back. So let's take a look at, make sure that works, and that's exactly what happens right here. And also, you can call these out of order. So if I wanted to simply call these out of order, since we're on it, I can do val2 1, and then I can do val1 as 6. And so this would add, or let's just say 9, so we're not going to get a confusing value here. So this is going to add 1 and 9 together, but I'm calling val2 first and val1 last. Let's run that, and I get 10. That's exactly what I expect. So let's look at this right here. Let's set a default value for my input function right here for get number. Let's just say this is going to take on nothing for the var name. So input a value for var name. So I don't want to display nothing here. So I'm just going to create a condition around this. So if var name equals empty string, display something, one thing else, do like we see here. So I'm just going to basically copy and paste that code, enter a numeric value, and take this out. And that's what I'm going to prompt for if they don't input something for var name. So that is, if I just say get number without a parameter or any value, then I can simply just say enter a numeric value and keep looping until they enter a numeric value. So let's try that and see what happens. So let's say print get number, no parameter passed in, nothing going into get number. So it's going to take the default value right here, and then it's going to enter into line 8 right here. It's going to give me this input right here. And then I'm still going to have to enter a numeric value and to exit the program. But at the same time, I can use that same function without a parameter if I just don't want to pass one in. So let's call that, and it's going to say enter numeric value. So it's inside of this code block right here. And, you know, again, not going to let me enter anything until I enter in something that's, you know, numeric. 435 is numeric. And so that's why I can call that same function. If I was to pass in a var name, it would simply go into this else, and it would get some variable name, and then put it right there. And then it would not display, it would display this prompt rather than that prompt right there. So this is one way that you can use default values to help massage the flow of your program, to make things a little bit more dynamic. Default values are good for making sure that people don't enter junk into your code or into your function, and that way you can control the flow of your program using functions as well. I want to talk about one other cool thing you can do with functions, and this is a style of looping called recursion. Now, recursion is when a function calls itself. Now, we've seen where you can use a function to call a function. So we had a function that called the print function. So you can have functions inside of functions, but you can also call a function within itself. So it can just do self-referencing calls, but you need to create an exit condition, just like we saw with for loops and while loops. You need to have some kind of terminal condition so you don't end up with an infinite loop or infinite recursion in this case. And this one is a function that calculates a factorial. So this one, I have an exit condition of where val equals 1. So a factorial is basically the sum of a number and every number before it. So if I say, what is factorial of 3? That's going to be the sum of 1, 2, and 3. So 1 plus 2 plus 3 is 6. So 3 factorial is 6. 4 factorial is 1 plus 2 plus 3 plus 4. So that is 10. And so I can then create a recursive function that will simply calculate that factorial using recursion. Of course, you could use a while loop to do this exact same thing. There's nothing that says you couldn't do that either. This is just one of the classic examples that you can use recursion for. So in this case, my exit condition is when I get to the first number in the sequence, which in that case is going to be 1. So if I get down to 1 factorial is 1. So that is simply going to return 1. It's just a hard-coded value that represents the bottom of the stack. Whenever I get to the bottom, that is 1. Everything before that then will start getting added to whatever it was. So in this case, if I say 3, I'm going to pass in 3 into my factorial here. What that's going to do is it's not going to take the default here. It's going to have a value of 3. And then it's going to evaluate the value of 3 that's not equal to 1. So it's going to come down here to this else. And then what it's going to do is it's going to say return val, which in this case is 3. And then it's going to add to it a call to itself, factorial. But in this case, the argument it's going to pass in is val minus 1. So it's going to wait until the subsequent call into factorial comes back with some kind of value. So then it's going to come back up here, and this is going to be called with 2. 2 is not equal to val of 1, and it's going to come back down here to our return. In this case, it's going to say 2 plus factorial val, which is 2 minus 1. Then it's going to call that with 1. And then it's going to hit the exit condition. And then it's going to start going back up the stack. And then it's going to say 1 plus 2. And that's going to return 3. And then it's going to take 3 plus 3. And then it's finally going to return 6. So let's step through this code. It might be a little bit confusing trying to explain this on a slide. But the idea of a recursion is basically where I have a function right here calling itself down here. And that's really what the gist of this is. But let's go ahead and create this in Tony so that you can kind of see it in action. I'll step through the code so that you can see exactly what's going on in the code. Okay, I have a new Python file here called factorial, and so I'm just going to gen up that factorial function that we just saw. So very easy to key that in. So I'm just going to call it factorial. And then I'm going to say val equals 1. And that's the default value of 1. And then inside of this, I need my colon, of course. I need to do if val equals 1, simply return 1, else return, and then I'm going to call I'm going to say val plus, and then I'm going to call factorial. This is where my recursion gets keyed in, torial val minus 1. So eventually I will get to 1 if I keep subtracting 1 from whatever I call into this. So let's call that. Let's call this with print factorial of 6 or 3. And so the factorial of 3 is 6. So let's call into this and then see what happens. Now let's call my debugger. Uh-oh, I need my colon right there, my else block. Let's call this, and now I'm on this line. So I'm going to step into this code right here. And so this is going to call into my factorial code right here. And now it's inside of this. So it's going to evaluate that. Val is not equal to that. Val at this point is 3 down here in my variables. And so it's not going to return to that. It's going to go down to my else. And it's simply going to jump down to this. So what this is doing now is calling factorial again. Notice what it's doing. It's calling val of 3. And so I'm going to step into this one. And notice what it did is it popped open a new window. Val in this case is 2. And you can see that each time I go into this, it's going to keep opening up a new window because I'm getting recursion going on here. I'm calling it multiple times in and of itself. And in this case, it's just doing an evaluation of 1. And then, of course, I get factorial of 1 right there. Val is 1. And so I should hit that first code block there. I'm going to return 1. And then that's going to go back to my original call right here, factorial of 2. And that is what is going to add 1 to 2 in this case. And you can see that. I'm going to val to 3. And now I'm back to my factorial, my original call right here. So I'm just going to go 3 plus 3. And that's going to return 6 right there. And now it's finally going to print 6. So you can see where I had each subsequent call into my factorial method using recursion, it was popping open a new window that was showing me the call stack essentially of every time I called factorial. So that's called recursion, where I have a loop-like structure with a function calling itself. I still need an exit condition, but if I have a function calling itself, I can create loops that way, just like I did when I was using while loops and for loops. Not something that you will use a lot in beginning programming, but if you get more mature as a programmer, using recursion can be very useful for a lot of different kinds of different tasks. And there's a lot of different things I've used it for in the past. I'm not going to get into all the details of that, but it's just one of those cool things you can do with functions. For the challenge this week, I want you to create a dice rolling simulator. So this is pretty straightforward. So basically what I want you to do is create a function that has 2 parameters. One is the number of sides for that dice, and the second is the number of dice to roll. So when you roll die, you typically roll them in a set. Typically, all of them have the same number of sides, and then you'll have 1 or 2 or 10, depending on the game you're playing. And you simply roll those die, and it's basically a bunch of random numbers at that point. So if I'm playing Monopoly, I use 2 6-sided die quite a bit, but if I'm playing Yahtzee, I use 5 6-sided die, or if I move some of those die off, I might reduce the count and I might roll 3 6-sided die, and you can change the values that you put into your function to simulate your dice roll. So once you have that function written, I want you to try a bonus, and that's to create a function that will control the user input, similar to what we did when we looked at our example a minute ago. In that function, I want you to basically only allow the user to input data that is numeric, but also control it so they can only enter in data that is greater than 1. So it's adding a little bit to that function that we just did. So this is a pretty straightforward example since I've given you quite a bit of the code already. And this is a bonus. Of course, you don't have to do this, but if you want to challenge yourself, feel free to do so. And then when the user enters in a value, that gets passed into the dice simulator. So basically want you to say, enter in the number of die. I want that to be greater, 1 or greater. Enter in the number of sides. I want that to be 1 or greater. And then pass those values into the dice simulator. And then that way you can get a simulation from the user that says, hey, I want to roll 2 6-sided die, or I'm going to roll 10 4-sided die, or however many die. You kind of get the point. So let's go over to our programming environment, IDE Tony, and let's see my example. I'm not going to show it to you, but I want to show you what I'm kind of looking for. Okay, here's my example I have pulled up. I pulled the code up so you can't pull the shell up so you can't see my code. You can see I'm using random, of course. Let's go ahead and run this. And so here I want you to be able to enter a numeric value for the dice count. So if I entered in ASDF or some string value, it's not going to let me, or if I enter in -2, it's just going to keep asking me to enter in something until I actually enter in a meaningful value. So this is the number of die I want to roll. Let's say if I'm playing Yahtzee, I'm going to do 5 dice and enter the number of sides. So 5 dice, 5 6-sided die, and that's just going to print out a list of random numbers then. So 3, 5, 5, 6, and 3. So if I was playing Yahtzee, maybe I'd go for a full house, and I would say keep these, keep the 2 5s, keep the 2 3s, and then re-roll the 6, and then simply run my program again. And in that case, enter the number of die and 1 6-sided die, and then I get my 6 again, and I get one more chance since I'm running Yahtzee, and try for that. No, and I just got 2 pairs. So you can see here I'm just using a little app to simulate dice rolls. So this is a very fun little thing. I programmed this on my calculator when I was in high school to play games with whatever I was doing in high school for board games and things like that. But you can program this in Python really easily, or any other language really. But I want you to use functions to do this. And this is a fairly straightforward way of doing it, but it will at least make you write 1 function, maybe 2. And we have some pretty good examples already for how you might want to go about doing this. So looking forward to seeing your submissions as always. And thanks for watching this edition of Cool Enough to Code. If you like this content, please consider liking this video, then clicking on the subscribe button to subscribe to our channel, then clicking on the bell notification icon and selecting all so that you'll get notifications when new content becomes available on our channel. You can also click on the share icon and share this video to any of your social media platforms. Sharing this helps make it more widely available for those who might be interested in coding. Also, consider following us on Twitter so you can see updates on Twitter whenever new content becomes available, as well as other announcements related to Cool Enough to Code. You can also help us out by becoming a patron on our page by going to our Patreon page at patreon.com/coolenoughToCode and then clicking on Become a Patron. And there you can find out more information about how you can support our work with Cool Enough to Code. And like always, you can check us out online at coolenoughToCode.com. There you can find a schedule of all of the upcoming lessons that we have. You can also find out more information and reach out to us online here. And you can also watch the live stream as it comes out each week on coolenoughToCode.com as well. And like always, thanks for watching this lesson on Cool Enough to Code.